This is live.
Hey, everybody. Welcome to another show and tell. It's me, Lady Ada. With me is Mr. Lady Ada.
Yeah.
With a 3D printed heart.
Yeah, I've been called heartless, but now it's a fact. You've taken my heart.
Yes, I have taken your heartless, and I am double-hearted. And we're broadcasting live here from the Adafruit factory. This is my desk back here where I do all the engineering. And behind there, you can even see some of the machinery. Yeah. And we're going to be doing a show and tell. That's when you, the viewer, show off what projects you're working on. Come by. Tell us your latest deets and demo it off. We'll be here till 7:55.
Yeah.
Pardon me.
Okay, we're going to start with John Park.
Again.
John Park, what you got going on this week?
Hi there. Hey, so this week I have a little video that I'm working on. It'll be out tomorrow, I think, and it's a kind of a twofer. So what I'm showing is a little level shifter that I'm using. This is the 8-channel level shifter. So that I'll be able to power 8 different strips of NeoPixels for a later project. This allows me to use the 3.3 volt microcontroller with the 5 volt NeoPixels. And I'm also showing just transferring your project from a breadboard into one of these nice little perma-proto boards. So this will be helpful for people who haven't done that before and want to know how to make their project a little more stable.
Okay. And nice. We'll be looking forward to you. You have a guide coming out, and you also have a video.
Guide and video, yes. And this is actually part of, I'm going to be doing a really large, not really large, but pretty large 7-segment display. And so I'm using a lot of NeoPixels to do a timer for a Ninja Warrior training course. So
of course.
Look for that.
Okay. All right, Tony, you ready?
Hey, yeah, sorry. Dealing with some technical cat difficulties here. Of course, she has to sit down right where the keyboard was. And just a second ago, she discovered where I keep my little micro SD cards for the Raspberry Pi.
That's what cats
those
do.
Look like quite exciting cat toys. Anyways, though, so yeah, real quick, I just want to show off. I'm working on an arc reactor project. So this is for a cosplay that I want to do at the Emerald City Comic Con. So I'm going to go as Tony Stark, which fits well since I'm a Tony. So only Tonys can cosplay Tony. But this is basically his power plant that I think it powers an electromagnet that keeps a piece of shrapnel from cutting off his heart or something kind of horrifying like that. But this is kind of cool. And so I'm going to make mine do different animations and light up in different ways, because I think in the movies it's kind of boring. It's just a blue glow. And, why not add some style to the arc reactor? Like, I'm going to put different colors and animations for it. So, if you're going to have this like really prominent thing on your chest, make it fun. Like make it maybe even like smart, like control it with a phone or something. That'd be kind of fun for it. So, but what it's built from is just this little 24 NeoPixel ring and a circuit playground. Now this one, at the end of the week, I'm going to do a little live stream. This is the SAMD21, and I'm going to make a Circuit Python arc reactor, which hopefully is the one that I'll have at the Seattle Comic Con later in the beginning of March. I think is when it is, March 2nd. So.
Okay. And folks want to find more about the Comic Con and maybe meet you, Tony, a famous Tony engineer. Where can they find out more information?
Yeah, so I'll be there on the Saturday, which I believe it's like March 3rd or March 4th. So check out that Saturday. I'll be there walking around, and you probably won't miss me. I'll be in this shirt with the arc reactor here. And I'm thinking I might bring an electronics first aid kit. So have like a little soldering iron. So if you're doing cosplay and if like a wire breaks or something, I might be able to help you with it. So seek me out.
Kind of like your little toolkit when we went to Burning Man.
Yeah.
You brought an oscilloscope.
And oscilloscope.
Smart.
A lot of EL wire. EL wire breaks really easily.
Ouch. Yep.
Okay. Thank you so much, Tony. And thank you, Carmen.
Oh, yep. She's gone now.
All right. Chris Young, how's it going, Chris?
Hey, Chris.
Can you hear me?
Yeah, you sound great.
Okay. Well, I just wanted to tell everybody that I published a new guide on the Vermi system, and it's how you can use Adafruit LE to do switch control of an iOS device for a disabled person. If you're not able to touch the touch screen, but you can push a couple of buttons your iOS that allows you to scan through the icons and click on them and do just about anything you would ever want to do on an iOS device, except maybe play some fast game or something. But you can do it all with a couple of push buttons. And that's the system that I used when I was in the hospital recently, where I couldn't talk. I needed to use my iPhone to type messages to the doctors and nurses. wanted to tell you a quick story about that. People were fascinated by the technology, and several of them would say to me, "Hey, you ought to patent that and make a ton of money off of it." Well, how about I release it open source on the internet, and then anybody else that wants to build one can build it for the price of the parts alone. And then they get this real embarrassed look on their face when they realize how greedy they were and how altruistic I was. Oh, yeah, that would be a better way to do it. I mean, these are doctors and nurses. You'd think they would be people with lots of empathy and caring about people, but their number one guess was, "Hey, you ought to patent that and make money off it."
Yeah, I think it's those late night commercials where it's like patent your idea.
Yeah. So anyway, I had fun kind of going back at it like that. Anyway, the guide is out there, and I've already had some positive feedback about it. And people can build their own devices now. So that's all I got for now.
All right, and
Awesome.
you use that to send us an email, right?
Huh?
Didn't you use that to send us an email when you were recovering?
Yeah, that was the hospital. I just send an email and post on Facebook and
Yeah,
do virtual anything you want with an iPhone or an iPad. So
yeah.
anyway,
All right. Well, thanks so much, Chris, and thanks for doing the guide. It's just published, and thank you, as always, for thinking about others and getting the information out there. It's very much appreciated.
okay.
Okay, you get as many stickers as you want. All right. Next up, Scott. Hey, Scott, how's it going? Unmute your mic and show us your project.
So I'm working on a project. It's kind of hard to see my bike in the background here. I have a
All-terrain bike or something.
Whoa, that's like a fat bike.
fat tire bike,
Yeah.
and I'm building a bike for the Playa. And I decided to take a little uncanny eyeball thing here,
Oh, yeah.
and I put a NeoPixel ring around it, and mounted it into a
Neat.
classic bicycle headlamp. So it's got a chrome cover that's actually mounted on the bike right here. And so the idea is I have two of these eyeballs, one on each side. And then I'm going to have, so I have two teensies, one in each eyeball. I'm going to connect them with I2C to try to get the eyeballs in sync. So when they move, they'll both move together. Otherwise, they kind of go randomly.
Yeah.
You never know which eyeball to look at because it's kind of going off. And
Yeah.
so I've got a little work to get the synchronization to work between the two. And I'm going to put like a little joystick on my handlebar so I can like move the eyeballs around, and then do some stuff with the NeoPixels to maybe, animate the NeoPixels when the eyeballs go. I don't know. I just started on it and I'm like, I don't know, what can I do with this?
Yeah.
So,
The big question is, why aren't you waiting until the last second to do this? Like all
Yeah,
Burning
this
Man
is really
projects?
weird. It's
Why are you
like-
doing this so early?
Is this for last Burning Man?
Yeah.
Like,
it's left over. No, it's, I wanted to have some time to do all the weird stuff. And yeah, I should do it like a week before, right?
Yeah,
Yeah.
exactly.
and then like email us at the last minute. Like, I broke
Can
it.
you ship to the Playa? Yeah. All right. Well, email support@adafruit.com. We'll send you an as seen on show and tell sticker, and email me pt@adafruit.com if you want to do a guide or something like that, because you have plenty of time to fall behind schedule.
Exactly. Okay, we'll do.
All
I
right.
can't wait till you just freak out all the people at 3 a.m. who are like
Yeah.
tripping on like the Playa, and they're like, "Oh my God, these eyeballs are coming!"
Yeah.
Maybe I should keep them going off in different directions.
Yeah. That bike has eyes. All right. Okay.
Watch out.
Next up.
I bite.
Hey, Carter. How's it going?
Hey, it's Carter.
Oh,
Okay,
hey, okay. So got the mic this time, right?
Yep.
Hey,
You sound good.
nice.
Okay, great. That icon, I get that icon wrong every time. So I'll show, I saw it looked like the room was light, so I just kind of jumped in, but I do have a few things I can show. So let me switch to here.
Whoa.
Basically, I've got a couple PCBs that I got around to making. I realized it's been like over a year since I've done anything in Eagle, and I was trying to find an excuse to do something.
Which version
So I
of
got a
Eagle?
game of-
Which version of Eagle are you using? I'm asking for a friend.
0.4 beta. No, it's like a 6.3. Whatever.
That's safe. It's safe.
Safe.
Yeah. Whatever one of the free ones was.
Okay.
So this project, when it gets finished down the road, I'll come show it. But basically, it's a game of life using two of the 8x16 matrices to make a 16x16 setup. And there's a couple rheostats that can change some parameters like how fast it goes and whatnot. all being driven by a high zero. So one thing I decided to do, which is totally overkill, was to make a hat or whatever you want to call it for a zero. It's nothing more than just a breakout for that ADC, that SPI-based ADC. And then some convenience connectors for hooking up to the display, et cetera, et cetera. So I went with a zero because I have the idea of I'm going to have some web interaction with this, so you can basically set up displays interactively and let them run and see what happens, and log a bunch of data about what starting display ends with what kind of results, et cetera, et cetera.
Name of Internet of Things.
Yeah, and it was kind of interesting too. So one thing I did on this was trying to play around with silk screen. So on the back of it, I made like cells, since it's about game of life and cells and stuff like that. And this end result I didn't really like. That was very distracting when I was trying to solder all that kind of blotchy white silk screen. So I've kind of made a rev of that. So that's one thing I did. And then another thing I did was related to thinking about how to get circuit playground stuff married with breadboard stuff. So if you wanted to do something circuit playground with, interact with the breadboard, how do you go from this to this? And there are these cables, of course, which work great. You just clip them on, and then you can go straight into the breadboard.
Yeah.
But if you wanted to stick with the standard just gator to gator, I was trying to think of a way to do that. So I came up with, this was just something I just did for fun, this thing I call the Gator Tiara.
I grew up in Florida, and I actually think you can buy this.
I just took the circuit playground, cut it in half, and threw everything away, so it's basically the exact same size. So, you know, it's kind of familiar kind of hookups. And then it's a 90-degree little header pin.
That's cool.
Throw that in on the breadboard. And then there you go. There's basically no label. It's just all about the silk screen. There's no ones or anything like that to do it. You just follow the silk screen down to the headers and clip on however you want. And then off you go. And that was also kind of a cool learning lesson, because I'll switch back to the desktop here and show what was in Eagle and what actually got. You know, so I just basically did a very simple silk down to the thing. And of course the design rule check complained about all this interfering. And I was expecting to get a nice clean cut on the silk and the copper, but instead, you know, you get this kind of re-chamfering of the line. So that was just kind of a good learning experience on.
Are you sure that isn't your PCB house that made that change?
You know, I haven't done enough of this to really know where the blame is, but
they often do. I mean, I'm just telling you, they often do. They'll move silk screen around. Sometimes like pick up parts and like move them the way they think you want it, because it's unusual for them to chamfer it that way. Like it's unusual for the Gerbers.
Yeah, I figured it was because this is more of a vector thing than a bitmap. You know, it just basically re-terminated the thin line and re-ran the whatever does the production. So the edge effect became that.
Yeah.
But anyway, so there you go. A couple of PCBs, a couple of things I learned.
Neat.
That's great. And then for the folks tuning in live or later, Carter has a ton of great tutorials on the learning system. The name of that little circuit playground adapter, I was thinking, so in Florida, the gators would eat poodles once in a while, and they'd find the gators, and then they would get the leashes or the collars. And I don't know what that massive poodle that was eaten was called, but that's what it reminded me of. Was that my outside voice?
I have to live with this guy.
Yeah, okay, all right. Thank you so much, Carter.
I think it's
yeah, it's a poodle. Puddle. Okay, all right.
Polyp.
Right. Next up, Bill. Hey, Bill, unmute your mic and show us your project.
Hey, Bill B.
How are you?
Good.
Hello, very good, very good.
Okay.
Yeah, you sound great.
Good. So yeah, I have a couple things to show. Actually, I got to thank Noah and Pedro for some of this. So I've been working on AT Makers. I don't know if you guys have seen, you put something on the blog last week as well. T-nuts, and I can switch to an overhead if I have to, but I think you can see in here. I'm using T-nuts to convert little 3D printed holders to put AT switches in. And AT switches are ridiculously overpriced switches you folks use. Like this is one. It's actually one of the better ones. It's a proximity switch. It uses infrared, but it has, of course, no way to mount it. Do have ways to mount them are non-standard, and then they sell you very expensive mounting gear. So our approach here was to basically make things that would take things like this eye gaze device, then having the strange little, in this case, M3 screws. We just went ahead and put a 1/4-20. You can see there's a 1/4-20 socket now, and so you can put it on any camera mount. So you can go to Amazon and get any of the 3,500 camera mounts that are out there, and screw it on. And this one's $20. This is one of the articulating arms that, the single screw that locks down.
Yeah.
These are great. And it turns out the T-nuts are a big hit. So Noah and Pedro are adding them to theirs as well.
Yeah.
This is something you can print. Any high school can do it. And that's really what our goal is. I think you guys probably know that. Our goal is to get high school STEM programs making assistive technology. And this is something where if you have an idle 3D printer, you can print these, stick in a 20-cent T-nut, and make the switches much more useful, much easier to support. And so that's kind of what we're doing. So that's atmakers.org, a little plug, sorry. But by all means, you guys have been a huge help. So I actually had Pedro help me print these in ABS, which was a challenge. They're really small and they warp real easily. And he told me the trick was to print 2 at a time on opposite sides of the bed.
Yeah.
That's what I thought of. But that was great. So it's been a lot of help. And we do other stuff too. We're actually, Chris Young on here is active in our community as well. It's great to see him again. I'm glad you're healthy, Chris. Yeah, you guys have been wonderful. And thanks for the pushing out the blog posts and things like that.
Absolutely. Thank you, Bill. Of course, email support@adafruit.com. We'll send you an SU on the show and tell sticker. And thank you so much for what you're doing. One of the things that we learned is 3D printers are sitting idly. And if you can get kids to use them and then bring the things out into the world, they'll talk about what they printed, what they did, and if it's a useful thing, even more so. So thank you so much.
If anybody out there is in a robotics club and you need an outreach program or you need something, just come see us. We will get you started. We'll give you projects. We have our own mini learning. By the way, Lady, I love the idea of, we're a tutorial company with a gift shop. AT needs that. AT is about 10 years behind. And it's primarily because of how the funding works, right? It's all broken. But I love the idea of it. So I'm trying to steal some of your...
Steal it.
Yeah, and Bill, if you ever want to try your hand at authoring a guide and use the system for one of these projects, let us know.
Sure, I'll be happy to. That'd be great. Thanks.
Thanks so much, Bill.
Sweet.
All right. See, Scott, play us out.
Hey, guys. Today is a tale of just when you think you really know a circuit really well, it goes and does something funky and makes you wonder what the heck went wrong.
Okay.
And I'll start with, in 2003, 2004, I built this 5U version of what I call the GX1 bandpass resonator.
Right.
I probably showed that. I think I showed you one of these on the very first time I ever showed up on one of your shows, like 5.5 years ago. Anyway, flipping over to here's the schematic, because schematics tell much better stories than I do. Here is what it looks like. What you have here is just voltage controlled active summing network. But the interesting bit is this. This is a diode ladder resonance cell. I use transistors in a little transistor array in place of the original diodes that were used by Yamaha way back when. And I built 100 of these. They worked fine. They worked great. And people use them all over the world. Okay, I went to make a Eurorack version, which oddly enough looks very similar. That's the schematic. And let me pop out real quick here to show you. This is the little 4 HP Eurorack version. Same thing, just a different shape. Okay. It doesn't work. And I spent several days going, same circuit, same topology, same parts. I built one specifically exactly like my original one from 2004. Didn't work until I hit upon the idea that there is, in this particular transistor array, this transistor at the top here, let me put me back on the schematic so you can see what I'm pointing at. This transistor at the top of the schematic right here, we call this the substrate transistor because its emitter is connected to the substrate, and what you want to do is bias the substrate down to the most negative potential in your system, because each collector in these transistors has an integral diode to the substrate that you reverse bias to guarantee isolation of one transistor to the next. Well, those diodes are, and here we go to my explaining what I finally figured out. Here's the one of those transistors in the array. This is the integral diode that goes to the substrate that you're pulling negative. The thing is, you're using the diode junction, this BE junction. Here's your anode and cathode. You're sort of letting this collector freewheel. It's just floating there. That forms a capacitor, because you have the unconnected diode, the based collector, and you have the connected diode, the integral diode. If you've ever seen the schematic symbol of a varactor, it's two diodes rammed with the cathodes together. You have a tuning diode, and it has a certain capacitance that we call the Miller capacitance. It's just something that arises out of the p-n junction. And what happened was, since I made there was one tiny little change that I made between the, let me off the schematic. One tiny little change I made, and here I built the original, this is my original prototype Osh Park board, has a little through hole 3046 on it. And here is, production model. The only change I made was this is now a surface mount version, because it's hard to get the through-hole versions of their 45-year-old chips. The difference was they changed the process node. In other words, they make the way they make the chip, they etch up everything in the metallized layers on the substrate. It changed the capacitance that I showed you in that schematic. Let me go back to the schematic real quick. So that this capacitance was so high, it was biasing this diode on, this one, the base collector junction, through the capacitor, because the AC impedance had gotten low enough that I was seeing a full voltage drop, and I shouldn't even see the diode being turned on at low control current. We're talking like picoampere control on it, like 250 picoamperes or nanoamperes. But to finish off, in order to fix it, we just get rid of that capacitor by joining each base and collector together, so that you cannot have that capacitance there anymore. The only capacitance you would have is from the integral diode, and it isn't in the picture. It's reverse biased. It's the forward biasing one that was causing us the problem. It works. It now works perfectly. All I had to do, let me flip back to me one last time here. All I had to do, and it may be tough for me to show it on the camera. Okay, you see the little hacks I did to the SMT chip? I bonded pins 1 and 2, pins 4 and 5, and pins 8, 9, and 11. I did that, and it works perfectly fine. So the moral of the story is, no matter how well you think you know a circuit, it will find a way to come back and surprise you. And this was my tale for today.
I feel like there was a Sparky the Blue Smoke Monster. You need less capacitor.
I'm personally weirded out whenever I see floating transistor elements. I don't like it. I'm always like, connect them together.
Like
I don't like floating emitters or floating bases. It's just like, I know that it's connected to the substrate, but at first, when I first saw it, I was like, whoa, that's really weird. But like, I guess if you're supposed to connect to the substrate, but it's kind of like sets me on edge,
Okay.
Well, it worked, is the thing. It worked for a dozen years, and then all of a sudden it didn't work. And when you're used to it working and never having the first hint of a problem, and all of a sudden, I had to build 3 of these to get one that didn't work, because it's like some sort of edge case. And I had people out in the field making them saying the filter doesn't run; it just squelches all the volume and whatever. But yeah,
you never know.
Study, and here is your. Let me go back to the.
I've seen mismarked parts. I've seen PCBs with vias that don't actually go all the way through. You'd be like, there's things the things you don't expect to.
Hit the X-ray board sometimes.
Yeah, it's of course, they say it's the last thing you check, but sometimes it really is your last assumption.
So yeah, the AC the AC impedance of these two diodes is causing this one to forward bias, even though this one was reverse biasing. There was an AC component leaking through, screwing up the conduction of the diode, and that stopped the circuit from working. That's it.
All right, we figured it out. Good work.
Well, thank
How
you
to
so much.
figure out what went wrong a dozen years after it was right.
And I see you're using Eagle 7.30. It is safe.
Yes. Oh, yes, yes, yes. Eagle now annoys me, asking me to upgrade to version 8. Like, no, no, thank you.
Not safe. Okay.
Not safe.
All right. Well, that's our show for tonight. Thank you, everyone. We're here every week, 7:30 p.m. Eastern Time. Thank you so much, Tony, Scott, John, C. Scott, Chris, Carter, and Bill. We'll see everyone on Ask an Engineer in a few minutes. And thank you once again, everyone, for making this the best half an hour of our week, every single week. We only have 3D printed hearts for you. All right.
You soon that'll be a working one.
Yeah. I'm catching up to it.
Wish I could feel this like goop and I get squirt, squirt.
We will.
That'd be your Valentine's Day gift, a 3D printed heart.
Yeah.
That's awesome.
All right. We'll see you all on Ask an Engineer in a few minutes.
Yes.
Bye-bye. We have a camera back too.
Yeah.
Bye-bye.
Hi, camera.